In this problem here, we have a set containing several natural numbers, and we define a correspondence in it, which is x is related to y if and only if x and y have exactly the same prime divisors. And we have to do one or two things. First, prove that R is an equivalence relation and then calculate the equivalence classes. Or otherwise, if R is not an equivalence relation, determine which properties are missing. Okay, clearly the answer is A, because it's very easy to show the three properties of an equivalence relation. First, of course, x is related to x because x has the same prime divisors as x, obviously, so it's reflexive. Okay. Then if x has the same prime divisors as y, then of course y has the same prime divisors as x, obviously, so it's symmetric. And finally, if x has the same prime divisors as y and y the same prime divisors as z, then x has, of course, the same prime divisors as z, and then this is also transitive. So it's got the three properties of an equivalence relation, so R is an equivalent relation. Okay, good. Now the next thing to do is to calculate what are the equivalence classes, and for that what we need to do is to classify all the numbers in the set, all these numbers here, according to the primes they have. And here's a small table which shows you those prime factors. Okay, here you are. Right, these are all the numbers in the set. This is the corresponding factorization, and you can see that there's the only factors that appear are 2, 3, 5, and 7. And here with crosses are marked those factors that appear there, right? So according to that, we have the following classes. So first, the equivalence class of 2 times 3, which is 6, right? 2 times 3 are those numbers, including 6, which only contains the factors 2 and 3. And these are, of course, 6, but then it's also 12, right? And there's also 18. Okay, and no more, right? Those are the only 3. All right, so we already have these 3 numbers, this, and this. Okay, now we go for the 10. The 10 contains 2 and 5, so this and this. And if we look here, we see that 40 is another one having the same 2 factors and no one else, right? So we already have this and that. Now we go for the 21, right? Which contains, of course, the 21, and the factors are 3 and 7. So 3 and 7, and as you can see, 441 and 1323 is another one, and that's all, right? So we have already this, and that. So all of them are classified, so this is the partition, so these are the equivalence classes of this relation. All right, so there you go.